Hello, geometry folks. Today we're going to be talking about reciprocal trig ratios. And we'll talk in just a second about what that means. So what you'll need today are your notes, which require no foldable, a pen or pencil, and a calculator if you really want to, but you don't need one. So let's consider the trig that we've learned already. When we're talking about trig ratios, that's the acronym SOHCAHTOA that everybody remembers: sine, cosine, and tangent, with sine of theta being the ratio of the opposite side over the hypotenuse of our right triangle, and then the cosine of theta being the adjacent side over the hypotenuse, and the tangent of theta being the opposite side over the adjacent side. Those three ratios, we should be pretty good at recognizing those three. And if we still have a little bit of trouble recognizing those three, let's remember SOHCAHTOA. And let's first of all remember that this is how we spell SOHCAHTOA. So it's at this point that you want to pick up your pencil and title the next section of your notes, the three reciprocal trig ratios. And those three ratios are cosecant, secant, and cotangent. That's how we say these acronyms, but they're going to be abbreviated. Like, for example, cosecant is abbreviated CSC, secant's abbreviated SEC, and then cotangent's abbreviated COT. So if we think about what we know about the word reciprocal, let's think about if we had 3 over 4. The reciprocal of 3 over 4 is just going to be 4 over 3. We switch the denominator and the numerator and we flip-flop them over the fraction bar, right? So if cosecant, if CSC theta, which is pronounced cosecant theta, is the reciprocal of sine of theta, now we're not going to have the opposite over the hypotenuse. We're going to have the hypotenuse over the opposite. So some people will show you that cosecant is the same thing as 1 over sine theta. What they mean by 1 over the sine of theta is the reciprocal of sine. So that's going to result in the ratio hypotenuse over opposite. So if we look at secant, which is the reciprocal of cosine, my new ratio is going to become not adjacent over hypotenuse, but hypotenuse over adjacent. And last but not least, let's take a look at cotangent. And cotangent's the one that's easy to remember because it's the reciprocal of tangent. And tangent, remember, is opposite over adjacent. So now the ratio is going to become adjacent over opposite. So these are three new ratios that we can add to our trigonometric ratios. So we have sine, cosine, tangent, and now we just learned cosecant, secant, and cotangent. So let's look at what we would do with these trig ratios in some examples. Number 1, or example number 1, given the one trig ratio, find the other 5 ratios. So we've been given that the cosine of theta is equal to 4 over 5. So before we do anything, we need to find out that third side of a right triangle in order to use all 5 of our trig ratios. So first, what I'm going to do is I'm going to draw an arbitrary or a random right triangle, and I'm going to label an angle. It doesn't matter which one I pick. I could pick the top angle or the bottom angle, and I picked the bottom angle to be theta. So now, in relation or in reference to theta, we said cosine of theta is equal to 4 over 5. Well, remember cosine is adjacent, so 4 over the hypotenuse, 5. So now what we need to do is use the Pythagorean theorem. Let's call the tall side A. A squared plus 4 squared is going to give me 5 squared. So A squared plus 16 is equal to 25. Subtract 16 from both sides. That's a subtract 16. Sorry about that. A squared is equal to 9. Take the square root of both sides, and A is 3. So let's fill in that right triangle with the side length 3. So now we have the 3 sides of our triangle. What I always do to remember what to do is just fill out or write out all the trigonometric ratios that we know. We know sine theta, we've been given cosine theta, but we can write it down again. Tangent theta. And now we need to find these three along with our new three. Remember, sine is going to be the cosecant of theta, is going to be the reciprocal of sine. Secant of theta is going to be the reciprocal of cosine, and cotangent of theta is the reciprocal of tangent. So I always like to line them up like this, my 6 trigonometric ratios, so that I know that sine is the reciprocal of cosecant and cosecant is the reciprocal of sine, and vice versa. So now we can write all of our fractions because we remembered our 6 ratios. We already know that cosine is 4 over 5. So let's do sine theta next. So looking at my reference triangle that I drew, sine of theta is going to be 3 over 5, right? The opposite of theta, which is 3, that side, over the hypotenuse, which is 5. Now the tangent of theta, looking at my reference triangle or my right triangle, is going to be the opposite, 3, over the adjacent side, 4. As soon as I set up these three, you guys, it's so much easier to come up with my reciprocal ratios, because now all I have to do is flip-flop the denominators and numerators. So cosecant of theta is going to be 5 over 3, secant of theta is going to be 5 over 4, and cotangent is going to be 4 over 3. So hopefully that makes sense. The biggest takeaway here is that cosecant, or CSC, is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So try to memorize those reciprocals, and then maybe the homework tomorrow will be a little easier for you. Let's look at example number 2 now. We want to find all the 6 trig ratios given the angle theta in the picture below. Keep our answers in simplest radical form. Yes, radicals are back, people. Be ready. Okay, so just like the last example, the first thing that we have to do is find the hypotenuse of our right triangle in the picture. So we need to use the Pythagorean theorem. 2 squared plus 1 squared is equal to, let's say, c squared. 2 squared is 4 plus 1 is equal to c squared. 4 plus 1 is 5 is equal to c squared. Square root of both sides. That means my hypotenuse is going to be the square root of 5, and we do not want a decimal for that. So now we want to find the 6 trig ratios. So sine theta, cosine theta, tangent theta, and then I'm going to write, while I remember, that the reciprocal of sine again is cosecant theta. Secant theta is the reciprocal of cosine. And then cotangent theta is the reciprocal of tangent. So now we know what we're looking for. Let's first try to find the ratio of sine of theta. Remember, sine is 1 over the hypotenuse, or opposite over the hypotenuse, so 1 over the square root of 5. We need our answers in simplest radical form though, so this means that we have to multiply by the square root of 5 on the top and bottom, which is also called rationalizing, right? So square root of 5 times 1 is the square root of 5. Square root of 5 times the square root of 5 is just 5. Hopefully, fingers crossed, we are better at rationalizing the denominator, because we are going to need to do that quite a bit. Okay, moving on to cosine theta. That's adjacent over hypotenuse, which is going to be 2 over the square root of 5. Rationalize again. Some of you may be able to do this in your head by now, or hopefully 2 square roots of 5 over 5, because we took the top times top over the bottom times bottom. So that is my other ratio. And now tangent is going to be opposite over adjacent, which is 1/2. You guys, the reason why I kept the first ratios is so that they were easy for me to flip when we come to writing the reciprocal ratios, the cosecant, secant, and cotangent. Because now when I look at cosecant of theta, it's going to be the reciprocal of that first one, which is going to become the square root of 5 over 1, which is just the square root of 5, right? And then secant of theta is going to become the reciprocal of 2 over the square root of 5, which is going to be the square root of 5 over 2. So therefore, we don't have to rationalize these guys. So that's a little simpler. And last but not least, the cotangent of theta is going to become 2 over 1, which is also equal to 2. All right, I want to thank you guys for taking good notes. I hope that these make a little more sense. Just remember that cosecant, secant, and cotangent are reciprocal trig functions, and remember which ones pair up with sine, cosine, and tangent. No homework today other than this video, and then we will work and practice on some of this when we go to class next. I shall see you soon.